one and all present here. Okay. So am I audible? I suppose. Yeah. So we'll today keep my session a bit too restricted. Why? Because I plan to show something using our UAV. We have a UAV also. So that UAV has the possibility, which is a DJI drone, that has a possibility of communicating in using 5G new radio band, which is around 5.9 gigahertz. So we plan to show you a part of demonstration today, and also a preceding kind of a demonstration which we'll show on Thursday. So for that we have purchased one Mantis Wave, which is a 5G new radio SDR setup from our SERB CRG project. So we are going to show a small demo on that. But before that, obviously, we need to tell you what it is all about, okay? And that is the only reason I'll give you a short demo of what it is all about, and then we'll move forward from there, okay? So let's start. Talking about the 5G architecture, if you see, the most important thing which you will find in any 5G architecture is the three main things. One is your core network, the second is your radio access network, and the third is your transport network, and the fourth is your interconnect network. Now if you look over here, just give me a second. So if you look over here, you will find out that this core network is the most important part of any 5G architecture, because that is what controls the entire 5G architecture, and it is also responsible for the entire controlling, right from having the subscriber information till the till the amount of traffic it can flow, the data rate, everything is basically controlled by this core network. Then you have the radio access network, which is obviously consisting of the G node B. In case of 5G, we call those as the G node B, which is your base station. In case of 4G, we call it as E node B. In case of LTE, so obviously your radio access nodes means it is consisting of some radio nodes. Radio nodes may consist of base station, because base station has antennas transmitting as well as receiving antennas. So that's why the name radio access nodes. Now the third most important thing is the transport network. Without the transport network, obviously your data cannot move from core to your radio access node, or even to the interconnect networks. So these three are very important. And the other one is the interconnect network, because it is just not that your core network is a single network. So your core is also connected to the other core network. So one 5G new radio core network is obviously connected to another 5G new radio core network. And that is connected to a PSTN, which is the public switch telephone network, via which you are able to send your data through the public exchange. So any subscriber can actually use this 5G new radio band, provided it has the facility of both your core as well as your RAN. So that's the most integral part of any 5G architecture. Along with that, this network basically carries few distinct types of datas, or maybe traffic. If I may put traffic can consist of anything. So the most important thing over here is the control plane. So we have three things. One is your control plane, the second is the user plane, and the third one is your management plane. So when I talk about the control plane, it is basically carrying the signaling traffic. So you can see the signaling traffic marked with yellow, okay. The next is the user plane, where your user is mainly taken care of. So all your data, whatever you exchange, remember one thing, that before sending any data, right from our communication basic knowledge, before sending data, what is the most important thing? Your device or your user equipment must actually know the base station. So how do you establish a connection between your user equipment and the base station? By sending signals, which is also known as the control signals. So basically these control signals carries the signaling traffic. Is it clear? When I talk about the user data, it is carrying your user information, okay. And the third important, which I told, is the management plane. Basically this management plane is the administrator, which is responsible for the entire traffic, entire control, entire data communication. So that is the most important part, which is known as the administrative or the management plane. I think this, yeah, I'll better. Yeah. So, hello. I think without the mic it is okay, na? Yeah. I don't think I require the mic. So yeah, so that gives me confidence. Otherwise the mic goes here and there with my voice. I think it's good. Sir. Yeah. No, I am okay with it. Okay. Sound ठीक है? I think then you 5G setup, your entire setup needs to get configured first. Until and unless you configure your core network, or until and unless you configure your radio access node, you will not be able to communicate. So that's the most important, and that is why we say the administrative traffic is very, very important, as it is responsible not only for the core but the entire RAN as well as for the other utility functions also. So and obviously these are all times are prone to some threats, so you need to get your network protected also. Moving to the next slide. So this is what shows us the core architecture. You have a number of protocols, starting from the authentication protocol to the user datagram protocol to the UDM. So there are various protocols which are present. We will discuss them once we move ahead. And this is what forms the RAN, which is the radio access node. Okay, and we have another one which is known as the user equipment. So the user equipment can not directly connect with the core, but the user equipment connects to the RAN, and accordingly the RAN can connect to the core. So that is how your network is actually set up. Okay, moving on. So what we are going to today discuss is a setup of a 5G new radio. Now before I move to new radio, what is new radio? So there are two bands in which new radio actually works. One is the FR1, the other is the FR2. FR1 is a sub 6 gigahertz, which is obviously less than 6. We choose 5.9 because that is something which is most suitable for doing the 5G new radio communication. We have another band which is known as the FR2, which is 24 gigahertz and above. So usually what we have done, or whatever setup we have over here, is a FR1 spectrum is being used over here, which is 5.9 gigahertz. So moving on, obviously the SDR, or the software defined radio, which we have. Software defined radio, why do I call this as a software defined radio? Because in my box it is capable of both hardware as well as doing the software function. That is why the name software. So radio means it has transmitter, it has receiver, it has channel for sending information. So where you utilize both hardware and the software at the same time, you call that as a software defined radio. To be very simple. Obviously there are other definitions, but this is the most basic definition of what a SDR setup is all about. Now here what we have, or what we are going to show you on Thursday, we have a 5G network in box, which is also known as a NIB. Mantis Wave is the company which has given it to us. We have purchased it from there, and the best possible utility of this 5G network box is it gives us seamless integration, enhanced security, scalable connectivity, empowering operations along with speed and reliability. Because in India still work on 6G is at a nascent stage, and obviously having a 6G setup is very difficult at this moment. So what we have tried to do is that we have a setup of 5G setup, as I told you, a new radio setup with a 5G testbed is with us. So what we are going to show you over here is a simple setup of what 5G testbed solution is all about. Today we are going to show a basic, how a 5G testbed is all about, what are the basic components, what are the protocols inside that. Probably in Thursday's class you will be having a hands-on experiment. So please don't miss the Thursday's class, because you will be having a hands-on experience of how a 5G new radio setup or a 5G testbed actually works. So moving ahead, it obviously has various applications, starting from your terrorist operation response to the simple, it's a simple plug and play kind of a connection what we have, the testbed which we have. Obviously it is used for drone communication and control. We will show you one such setup today, which is the DJI drone setup. So I think with that help of that you will be able to get an idea how it actually works, and the intra-warship communications. So there are various applications of this 5G communication, if I may put it in this way, in case of defense and security, because of its robustness, reliability, customization. Along with that, there are other applications in border security surveillance. You have also some applications in disaster response, mobile tactical operations. If you need to do some tactical operations, I think there's nothing better than the 5G radio. It's similar to what a gaming experience gives you, like something, an advanced version of 5G where you get the ability, or where you get the feature of both augmented reality and virtual reality. If I may put it, virtual is where you get a feeling of what the virtual world is all about. That's what is your virtual reality. You get a feeling of what your virtual world is all about. In case of augmented reality, what is the difference? It is a real-time experience, but you have some virtual features added upon to it. Yes or no? So if I may put it, augmented reality, it is more of a real-time processing, but obviously it gets added on when you add some computer-generated data, or you add some virtual features to it. Whereas virtual reality is all about what you have seen in those virtual games using your sunglasses or your goggles, where you get to feel what is happening in the virtual world. And if I combine both these two, augmented reality and virtual reality, that actually gives you a feel of what your immersive nature or your metaverse is all about. That is what is all about 6G. Because in 6G we are very clear, except apart from these three major operations, one is which enhance mobile broadband, which is very high speed, very less, your latency, which is your delay time is very less. If you have to have a good amount of communication, your delay time should be as least as possible. And the third most important is MMTC, which we know is massive machine types communication. So you have massive number of devices getting connected, because at this stage you have in any communication which we see, it is not a single device which is connected to the internet, or single device getting connected to single device. It is multiple devices. And the most important thing is you have to understand, or you have to see how the traffic gets evolved, because one device getting connected to one device is a simple traffic, but you have multiple devices getting connected to multiple devices, and at the same time you have to maintain a very good throughput. So you understand at the end of the day, this is what is expected from 6G. So apart from these three, we also have this AI integration coming into the picture. We also have security features, for example, quantum security features getting added to it. We have digital twinning, etc. and etc. So that makes 6G a better communication, obviously a better communication paradigm as compared to what 5G is. But still, I would say there is what we have perceived or what we think is still far from reality, because it's still in the research phase. So moving ahead, some of the other industry 4.0, at this present world we have industry 5.0. What is 4.0, by the way? I think it's basically the use of AI, robotics and IoT, so that your system, your devices get more automated, more industry specific, and at the end of the day your device is able to give you a very high throughput along with a very low latency. So that's what makes industry 4.0. Obviously it has to be robust, it has to be secure, and some of the examples over here, as you can see, is sensor network management. This is how you manage your sensors. Factory flow management, very good example of what industry 4.0 is all about, because you're not only using the three features, which is IoT, AI as well as robotics, but at the end of the day you're also making it more automated, so that you are able to get an application where your manufacturing, where your entire processing becomes more and more automated and not manual. So that's what is expected. Other edge processing, most of who you work on communication actually know what edge processing is. So your, say for example, why edge computing has become so famous is because whatever we studied or till now, we know that the entire processing of your data takes place at the base station, because obviously that is what is the best possible way. You analyze, you send your data from the edges to the base station where your data is analyzed and then obviously used for further processing. But if you can do the same processing at the edges where your network is not so strong, where your signal strength falls, what are you saving on? You are saving on the latency. Second, your computation is as similar as what used to happen in the base station. So you're doing the same amount of computation now at the edge, so you're saving on the latency. So that is one very big factor what has made edge processing very easy. And the next is you are doing a real-time processing. So those two things make actually edge processing very famous. You also have drone for site inspection and tracking, which is obviously one more real-time processing, and along with what I told you is the feature of augmented reality coming into the picture. Talking about academia, obviously we have some flexible user equipments, we have some GUI based, which you are going to probably see day after tomorrow, which is a GUI based dashboard which we have, comprehensive 5G network solution, because at the end of the day these solutions are very costly. So what has actually happened is these startups have now tried to come into the picture by designing these test beds. Now the problem with test beds is you cannot actually make any changes to the hardware or the software. So what you have is they might help you in making minor changes, but at the end of the day that is their solution, obviously, so you cannot tinker much with those solutions. So that's also one of the disadvantages, if I may put it. And obviously in case of disaster management, where in case where there's an accident, where there's a natural calamity like a cyclone or a disaster like tsunami or any such, this your 5G plays a major role. Obviously it helps in localization, which is also one very important application. Underground mining, because we know that as we move down, it is very difficult to detect signals. So obviously 5G new radio, 5G communication has that ability of having this localization, perfect sensing, and obviously the accuracy is very high, but not as much what is expected in 6G, but still the accuracy is very high. Obviously you have some asset tracking, inventory management, where you have a large amount of database to be managed, so that there's nothing much better than this. You have some training and simulation. Your smart campuses are one such examples where 5G communication could be, 5G and beyond could be very much utilized. You have the academic offices, you have the corporate offices, because at the end of the day, what you require is very high speed, very low latency, large number of machines getting connected, so all these get applied to it. So coming to the 5G SDR setup which we have, so we actually have this 5G private box, which is deployed and managed such that we have a dedicated network within an organizational premise. So the setup which we have is obviously restricted in the local, because we are using it in our lab, so it is obviously having a coverage within the lab very well. We can take our equipments or we can take it using some user equipment, so it also has some distance, but not more than 20 to 30 meters. That's what the range is all about. Obviously it eliminates, for line of sight, I'm not talking about the non-line of sight at this moment. So it eliminates reliance on public telecommunication networks. What this box consists is basically a 5G core, 5G radio access node, and a radio hardware. It is compact and deployable in the sense this setup has everything. So we actually have this 5G setup box. Inside that we have a core, we have a RAN, we have some transmitting antennas, some receiving antennas. So that's why we say we have everything in that one box, which is a core, which is a RAN, and which is the radio hardware. The second is it is in simple setup. Why? Because it can be deployed anywhere. We can even bring it over here. We can deploy it anywhere as long as there is connection. Third is, it can be used for some critical applications for which 5G is very much essential. And obviously the connectivity is reliable in the sense it is tailored to meet your requirement. So if you require it for a short range communication, nothing better than this. So obviously So some of the key benefits, obviously the operational efficiency, because with the setup which we have, you can actually have a streamlined communication. Your data remains fully secured, even though we say that it is fully secured, but we've tested it using some basic data. We have seen your data remains more or less secured. It can be scalable. You can add. It is flexible. You can use it for any such applications, provided you know how to maneuver the hardware and the software. So you can add upon. You can add any more devices and make them connected. You can try to modify the software. So those features are actually possible in these test beds. Obviously some of the advanced applications are in IoT, in automation, And at the end of the day, this is a very user-friendly kind of a thing. So you can actually use it for any XYZ application. Now, second, this is what the 5G box is all about, what we have. It is customizable. You can change the code. For that, we have to obviously take the permission of the vendor or the company who has provided us. It is interoperable. It is possible to work in any environment. For example, it can work in 5G new radio band, it can work in 4G LTE. I'm not very sure whether it can work in 3G, but I think it can also work in 3G band also. It is third generation partnership project, which is 3GPP is one such agency which actually updates whether your device is a 5G compliant, whether it is a Wi-Fi compliant, whether it's a 6G compliant, etc. and etc. It is easy to integrate because the setup, is very easy to integrate because it has antennas, so inside this box, if you see, there is core, there is RAN, as well as there is this radio elements. It is portable, you can take it anywhere, you can bring it here, you can have it anywhere. It is cost effective. Even though we say cost effective, it is obviously cost effective with respect to the other, maybe the startups who are probably are involved in the similar business. I may put it in that way. And the most important thing which it has is a comprehensive dashboard. So you do not have to do anything. So you have actually a dashboard. So you have your transmitter. So you are actually, whatever happens in the transmit in the hardware, you are actually able to see in the form of a dashboard. It's similar to what an app is all about. जैसे आप एक app design करते हो, most of you have already designed an app. So similar, whatever you see in your app, the dashboard of your app, we are replicating the same thing in our system. So what we have is, now your question is, where is the dashboard? So we actually have a monitor. So this, whatever we have over here is actually getting seen on the monitor. So the monitor here acts as the dashboard. So this is the technology which we are using, which is a 5G new radio technology standalone. As I said, it is using FR1, 3GPP standard. FR1 is less than 6 gigahertz. Channel bandwidth, if I am using CISO, so there is a possibility I can make it CISO or I can make it MIMO. So depending on that, we either keep a channel bandwidth of 50 megahertz. Now 50 is the maximum, but mostly the experiments which we have performed, we see 10 megahertz is the most ideal one. We also have a 2x2 MIMO, where 2x2 means 2 transmitting antennas and 2 receiving antennas. The maximum throughput achieved is 130. The standard is 3GPP release 15 and 16, because as I said, as the standards improve, your technology also improves. You get more added feature, you get more updated features. So as per 3GPP 15 and 16, this 5G private box satisfies that. The maximum number of user equipments. So the maximum number of devices it can support at a time is 32. In our cases, I think we have checked it or performed using 3 user equipments, okay, at a time. The modulation which we can use, you can change the modulation schemes. QPSK, QAM, I presume most of you know what QPSK is, because it's quadrature phase shift keying. So you are using you are using 2 bits to encode one symbol. So 2 bits, one for every phase. Say for example, you have a 360-degree phase shift. So every symbol corresponds to, say for example, the first symbol corresponds to 45 degree, the second symbol will correspond to 135. So you are adding 90 for every such shift. So you have 4 symbols, total is 360, each having a separation of 90 between each other. QAM obviously is a quadrature amplitude modulation, so not only the phase, but your amplitude is also changing. And 16 is basically the number of symbols. So 16 symbol ka matlab hai, at a time how many bits you are using? 4 bits. 256 means 8 bits together, I think. Yeah. So that's how your logic goes about. And obviously it's an open source stack. That's what the core and the RAN is. And the operating system uses Linux. So similarly, at the maximum transmit power is what we have is 10 milliwatt. The duplex mode is both operating in frequency division duplex as well as time division duplex. The maximum range is 50 meters, as I told. The power supply is okay. We are using an SDR card, which is a USRP. USRP is a product of NI, National Instruments. The maximum sampling rate is 60 megabits per second. The user equipments which are supported is also very important. You see, so what we have in our lab is a OnePlus mobile, okay, whose SIM is actually compliant with the Mantis Wave 5G box. So it is not a normal SIM. जो आप normal SIM देखते हो वैसे नहीं. It's a programmable SIM. जो कि ना जो Mantis Wave का setup है, it is compliant with that. So that is why whatever changes you make in your user equipment can easily connect with that 5G box. No worries. Today you just understand the basics. Thursday you will be able to do a hands-on what is actually happening. And the dimension of the box is this. So when I talk about the 5G private network, what are the steps? What we have to do? We have to first configure the core and the RAN, followed by the user equipments. Then we have to deploy them. So there's a button on the dashboard, start and stop. So when you start, so the start is like this. You first start on the core, then you start the RAN. When you stop it, you first stop the RAN, then you stop the core. That is how your entire process is. So the monitor is basically for visualizing. Now you have sent the data. How would you understand how many packets you have sent? So you have a monitor. A simple monitor will help you see the packets. So when you are sending a message, you will be able to see how your packets or how your throughput is changing. Log help in identifying what are the protocols has been used, because there's one I would say not a drawback in a sense but limitation, because आपका question was that if you are sending any data, how do I know that data is going to the receiver? Obviously you are seeing on the dashboard, but apart from that, you can follow those logs, you can study those logs and then say what kind of a protocol has been used for communication. That actually helps you in understanding. The KPIs, what are the KPIs? Key performance indicators. What are they? They are the parameters which help us understanding what kind of communication has occurred. And at the end of the day, you manage your resources. So you need to configure your resources, you need to add on subscribers if you want, and finally integrate them with the third-party apps if required. So that's how your setup is. So I'll just go through this. So the prerequisites is connecting the antennas to the SMA connectors. I think the SMA is basically the sub-miniature, जैसे आपके कोई भी setup और कोई भी devices है, आप वहाँ पे देखते हो there is some sort of a screw. Connectors basically, these are connectors. SMA is a sub-miniature connector, जैसे BNC connectors है. So this is also one form of connector which is known as sub-miniature connectors. A type होता है, B type होता है. So we are basically the connectors which are there in the 5G private box is basically your SMA connectors. So you are having those 4 antennas, 2 transmitter, 2 receivers. You are connecting those power adapters. Okay. Then obviously power connection, you know, आपको connect तो करना पड़ेगा, otherwise there will be no communication. Then you also connect the monitor. I'm not going details into this thing. Then you are integrating them, you are connecting them. So this is how your 5G radio setup looks like. The figure is not so good because so you have some USB ports over here. You have some USB ports over here. You can use this to add more number of antennas. This is basically your power connection. These are the 4 SMA connectors which I am talking about. ये जो 4 है. So you can actually connect those antennas over here. This is your Ethernet port, because if you need to connect it to the internet, you actually require this. So that is what it looks like. And one more important thing is that this LAN cable, because you have a LAN connectivity, that is required if you have to have a backhaul. If you have to have a network connection of this 5G private box also, you can use this LAN cable for that. Then obviously this is the login dashboard. You need to use your username and password to log in. So I'll not. This is what the dashboard environment actually. You'll be able to see this tomorrow. So this is what the environment. This is the core network. So these are all the protocols. UDM. This is the authentication protocol. This is the user datagram protocol. This is the server protocol. This is the user data plane and all these things. Achha, this will tell you the number of devices which are connected. So we are actually, apart from this 5G private box, we have also have one transmitter, one receiver. So when this experiment was performed, One is your mobile phone, which is the what was the company of that phone? OnePlus. So this one is, I think the one, this RNTI represents one as your I think the mobile phone. The other two representing a 5G box, which represents the transmitter. The other represents a receiver. You can please understand, you can add at a time, I think, some 30 user equipments together. So if you want, you can add more number of devices and see how the communication is all about. Okay. So these protocols are very important when you are setting up. We'll come to these protocols one after the other. See, in radio access node, as I told you, there is a base station. So this G node B represents a base station, and this packet flow, which is a log, tells you whether the core is connected to the RAN or not. Now here you see, these are in the screenshot which has been taken, your core is connected, but your RAN is yet to connect it. So it has to be also green. अगर सारे green है, इसका मतलब है कि all your protocols are working. You see all are green, na? So this means it is working. Okay. Here you see cross. What does it denote? कि your radio access node has stopped. So if it would have been showing the same thing over here, stop sign, it means that it is already started. But here you see your RAN has unfortunately stopped. So this is just an example. Okay. So these, so when I talk about the 5G core, please understand this is very, very important, because this is what manages and directs the traffic within the overall network. Some of the core functions are access and mobility management function. It is responsible for managing the user access, the mobility and the connection, because most important thing when you establish your core network, you need to first establish a network. You need to start your core network first. So जब तक आप core network को start नहीं करेंगे, there will be no connectivity which is available. So most important are these protocols. So as soon as you switch on your core network, because in the earlier slide you saw that all these are green, इसका मतलब क्या? All these protocols are working. Clear or not? So talking about this core network, as I said, it is mainly responsible for managing and directing the traffic. So these are some of the protocols. I'll just go through them in very short, because otherwise it would be too boring in a sense. So I'll just go through them one by one. So session management is mainly for managing the sessions, modifying the sessions, establishing the sessions. The user plane function is mainly responsible for forwarding your packet. Now data packet क्या है? आपका data, आपका information है. For example, in physical layer we call that information as bits. Data link layer में उसी चीज को क्या बोलते हैं? Frames बोलते हैं. जैसे हम network layer में जाते हैं, उसी same चीज को packets बोलते हैं. So on and so forth. But है वो same ही चीज है. It's information at the end of the day. So then you have something which is known as a unified data management. Now this is mainly responsible for storing and managing user related information. User related information मतलब subscriber के information है. How it is managed, how it is controlled, where it is stored, what is the location, etc. is all taken care by this unified data management protocol. You have an authentication server. Remember, what does 6G assure us? जो 5G उतना assure नहीं करता है security. So whatever communication you are doing, at the end of the day, you want your data to be protected also, to be secured also. So for that, some protocols are used. In this case, the protocols which are used is authentication server function. Now they are also using these public and the private keys to make the data secured. So management of keys is also very, very important. I'll not dwell much into these keys. Please understand that एक है public key, एक है private key, which is a part of an asymmetric key. Blockchain में simple architecture है. One is a public, one is a private. So public key is something which is available to all. Private key is something which is only available with the user. So अगर आपको symmetric key encryption चाहिए, तो आप जिस, say for example, ताला and चाबी, if I may put it in this way, कि आप जिस चाबी से लॉक किए थे या जिस चाबी यूज करके ताला को लॉक किए थे, उसी चाबी से आप उसको खोलेंगे. So both are same. So that is something which is a symmetric key cryptography. अगर आपका ताला एक है लेकिन दो चाबी है, so you are locking it with one, which is probably your private key. You are opening that with another key, which is known as a public key. So the private is only available with you. Public से कोई भी उस दरवाजे, उस key को, उस ताला को खोल सकता है. It's something like this. So that's what makes your data more and more protected or encrypted, if I may put it. You have something which is known as your network exposure function, because that actually protects your data from the third party, or that mainly not protects but authorizes your data for the third party applications. You have some policy, because in any 5G communication your protocols, your policies have to be followed. For this you have this policy control function. You have something which is known as the application function, which are very specific, very specific for XYZ applications. अगर आपको security based applications चाहिए, अगर आपको कोई specific application चाहिए, this will come into the picture. Last is unified data repository. Your data, whatever in whatever form it is, structured or unstructured or, so to make your data protected in whatever form it is, we basically take the help of a unified data repository, because it not only protects, it also manages, it also stores our data. It's something like this. अगर आप डायग्राम अच्छे से देखेंगे, you see all these protocols are connected. देखिए सारे प्रोटोकॉल कनेक्टेड है, and this forms your entire core network. तो सारे प्रोटोकॉल्स ये जो है, you see these are all connected with other. This N7, these are all the channels, control signals in a way. ठीक है? How these protocols are all connected. This is your user equipment. This is your radio access node, because यहीं पे base station has come into the picture. This is a RAN, I may put it. And you see, one of these protocols is also connected to the internet also. That's how your architecture of core looks like. Okay, let's move ahead. So let me tell you some more things about this box. The maximum sampling rate which you choose is 23 megahertz. The bandwidth is 10 megahertz. The transmitter gain is 80 and the maximum receiver gain is 676. Your question is, as we see over here, you will see these values to be normalized. ये 0 से 1 के बीच होता है. So these are normalized gains. Okay. And as you know, if my sampling rate is 23.04, इसका मतलब क्या? What is your message frequency? It is less than equal to less than twice that value. So obviously it must be some value which is less than 11 megahertz, maybe 5 हो सकता है, maybe 3 हो सकता है, depending upon what kind of information you have. So first, as I told you, first we have to run this core network, then we have to run this radio access network, and then only the communication would be set up. So in the 5G core network, all the 5 components, as you see, when all the components are green, then only your core network will start to work. Okay. And here, these are all active. You can look in this diagram. These are all active. So it means that all these protocols are in active state. They are all working. And as you can see here, your G node B. Why do we call this G node B? Because 5G में वही base station G node के नाम से बोला जाता है, because it's a part of 5G new radio. अगर वही चीज 4G में होता, LTE होता, तो इसका नाम G होके क्या होता, E node B हो जाता है. Because device to device का base station को we call that as E node B. So let's move forward. So as you see, then we configure how to configure. These are the protocols. So we here set up these values, mobile core packet. Then we have what is this? I also can't see. MCC, MNC, and TAC. So these are the values which you have to fit over here. MCC is, I think, probably called the mobile packet code. Okay. You have to also set up your IP. You have to set up the name. Acha, what would be the access point name in this case? What is the access point name in our case? Because the box is a 5G box produced by Mantis Wave, तो यहाँ पे आपके access point का जो name होगा, that will be Mantis Wave. And obviously you have some core network, you can save these values. So once you do that, and then what will happen is that you have to configure these values. Please remember, we cannot change all these values. Some of the values over here are fixed. ये जो values आपको दिख रहा है, all these values you cannot change. I think probably we can change these 3 values. ठीक है? The IP addresses, it is already coded from before, so most of the IP addresses we cannot change, but what we can change is these 3 values. Is it clear? And then we can save them. Once we save them, we then go to the radio access node. Similarly, in the radio access node, as I told you, you can set your sampling frequency, you can set your bandwidth, you can set your transmitter gain, receiver gain. What is this PRACH? It is a radio access channel nodes. So if you are using a 4G, you are going to use a LTE band. If you are using a 5G, it is known as a, I think I forgot what the P stands, but RACH I think stands for Random Access Channel Nodes. Okay, RACH is Random Access Channel Nodes, so you can actually configure these channel nodes. Because LTE के लिए इसका नाम क्या हो जाता है? It's a new radio band. So 5.9 GHz is the band which you can use. You can even change your modulation scheme also. You can change the QAM, you can change it to BPSK, you can change it to other modulation schemes. And this is what is one more scheme, which is time division duplexing. There are two things, one is FDD, the other is TDD. मतलब एक ही टाइम स्लॉट में आप एक बार अपलिंक एक बार डाउनलिंक दोनों कर सकते हो. व्हाट इज अपलिंक? एनी आइडिया? मोबाइल स्टेशन, बेस स्टेशन ऊपर है, हाइट में ऑब्वियसली द बेस्ट पॉसिबल वे टू आई थिंक लर्न इज व्हाट इज अपलिंक. मोबाइल स्टेशन का हाइट कम है, ऑब्वियसली इट इज एट उसका हाइट हमेशा कम होगा. सो अपलिंक इज फ्रॉम हियर फ्रॉम द मोबाइल स्टेशन टू द बेस स्टेशन. डाउनलिंक क्या है? फ्रॉम द बेस स्टेशन टू द मोबाइल स्टेशन. सिंपल. अपलिंक हाइट ज्यादा है तो अप, downlink height कम है तो obviously from up to bottom. Simple way to know these things. We move forward. As I said, how would you understand whether you have sent your packets or not? This is what will tell you. These throughput curves, the transfer speed, the signal to noise ratio, and the channel quality indicators. This will actually tell you what kind of data you have sent, what are the packets you have sent, कितने पैकेट आपने एक साथ भेजे, कितने channels आपने use किया, and all those things. At this example which we saw, we have seen so many devices connected. So at a time, I think what we have checked is more than 2 or 3 devices getting connected at the same time. अच्छा, you can also not only that, आप protocol को भी देख सकते हो. See over here, you can actually observe the packet logs of all the protocols. AMF, SMF, UPF, AUSF. You can also observe this. So there are n number of things which you can do using the setup, which the 5G private box which we have. This is one very simple experiment, how you connect your private box with a mobile phone. I think this would be very interesting. So first what we do is that this is a mobile. ये mobile का dashboard है basically. So first we go to, obviously you download and install the 5G setting app from the Google Play Store. Most of you know how to do this. Then what we do, upon launching the lab, a window will appear. We will select the phone information. Once we select this phone information, we will go to the next thing, which is selecting the preferred network. In our case, we are only selecting new radio because we want it to communicate in 5G band. So we are selecting this new radio band. Then we are also seeing that the data roaming gets enabled and your VoLTE calls get disabled. So we are setting up that also. Once it is done, we are naming this access point. As I told you in our case, what is the access point name? It is the name of the 5G box, which is Mantis Wave. So we are saving this. We are saving this to Mantis Wave. Once we have done that, we are practically setting up the protocols. These are two protocols which are very important, IPv4 and IPv6. These are the network protocols. Okay? So these network protocols are very important. Once we select these network protocols, what has now happened is we have finished, we have not yet finished. So now the last and the foremost step is we switch our mobile phone from the aeroplane mode to the mobile network. Once it's done, once this thing is done, it is expected that the user will successfully attach to the network. So your user, which is your OnePlus phone, got connected to your 5G box. Okay, and upon successful, so this is what is the radio network temporary identifier. ये जो RNTI का नाम आया था, हम लोगों ने कितने RNTI देखा था? 3 देखे थे. 3 किस लिए? 1 एक आपके मोबाइल फोन के लिए और 2 किस लिए था? 1 for the transmitter, the other for the receiver. So this is one app which is very important, is Wireshark. You have to externally install this app to actually observe कि आपने जो whatever information you have sent, how would you analyze those information? Till now, whatever, how do you understand if you have sent any information? How do you understand? You go to the command prompt and see, you go to the packet and see, you go to the logs and verify. But if you probably install this Wireshark app, you will probably be able to do something like this. So if you choose this loopback IO, you'll be able to analyze your packet flow. You'll be able to, so what you can actually do is that you can switch on your mobile phone, you can switch on your YouTube from the mobile. जैसे आपने YouTube में गाना या whatever आपने चला दिया, आप Wireshark जो ऐप है, there you can come and see how much packet you have sent. एक तो fast.com से you can check what is your speed, what is your upload speed, what is your download speed, but you can also see from where the packet has moved and to where it has reached. So you can analyze these things using this Wireshark app also. Okay, so this is what is your app. So you are able to see your source IP address, your destination IP address, you are able to see the protocols, you are able to see your length of the information and whatever information you have sent. So these things are practically possible. And obviously, so I'll just move ahead with these things because when I talk about the radio access channel nodes, this is how you select probably your index values. So index values will actually tell you how strong is your network channel. So that gives you an idea how strong is basically your channel. How much time we have? So we'll actually be keeping last half an hour, 45 minutes. So we still have some time, no problem. So when we are doing the real-time performance testing of this base station with some of the modulation techniques, what is the requirement we have? Why do I say my spectral efficiency improves with the higher modulation schemes? Most of you have studied your modulation, your communication theory. Why do I say 64 and with 256 your efficiency will be more? 64 का मतलब क्या है? You are using 6 bits. I think 256 means you are using 8 bits to encode one symbol. इसका मतलब क्या है? जितना ज़्यादा आप bit use करेंगे एक symbol भेजने के लिए, इसका मतलब क्या है? You are sending more information at the same time. So if you are sending more information, obviously your information being sent is much more. So you are utilizing your spectrum to the fullest. You are not leaving behind any band. So that's why we say your spectral efficiency improves. But what is the problem? If you are using these higher order symbols, you have to be, your system is susceptible to non-interference. So I'll just stop this, okay, because we need to take a break.